Okay, so this is going to be the solution of the modification to 5.2 that I assigned you to do this week. Alright, so let's start with, oops, that's not what I meant to do. Sorry, trying to grab this tool, get it out of the way. Alright, let's start by drawing the reaction forces in, okay? So they'll be here. That doesn't look very good. Try that again. Okay, that's going to be one of them. Here's going to be one of them. Okay, now think, which way is the reaction force in the x direction at A going to go? Is it going to go to the right, okay, or to the left? And we know it's going to go to the left because the only external x force is going to the right. Alright, so let's draw that one in there too. Alright, so the first thing we need to do is we got to figure a few things out about this triangle. Okay, so let's start with, we need to know some angles, okay, at some point, so we might as well just go ahead and get them now. Alright, so let's go ahead and do that. If I do what I know about this problem is that I have this height is 10 feet, okay, and this base is 8 feet, and that makes a good right triangle for me. So let's do it. The tangent of A is going to be equal to, alright, and what do we want to say that looks like? That's going to be the opposite, which is 10 feet, divided by the adjacent, which is 8 feet, okay, and so when we do a little rearranging on that, we're going to get the arctan of 10, oops, of 10 divided by 8 is equal to the angle A. So from that we get that A is equal to, I get 51.3 degrees. Right? And let's go ahead and do C in the same way. The tangent of C is going to be equal to the opposite, which is 10, divided by the adjacent, which is 16. See right here on the bottom. Okay, so from that we get that C is going to be equal to the arctan of 10 divided by 16. So C is going to be equal to, I get 32 degrees. All right? So that begins to give me some information I know I'm going to need about my triangle. Okay, so now let's look at external forces. Okay, and we'll just do because we're going to find the reaction forces. So RAX, oops, RAX, to find that we need to do the sum of the forces X is equal to 0 is equal to, alright, this is in our traditional positive direction, so it's 10 kips minus RAX. So from that we're going to get that RAX is equal to 10 kips. Okay? Now let's do some of the moments about A. Okay? those are also going to be equal to 0. Okay, and our AX and our AY won't make a difference because they're applied at the point. Okay, remember we're going to say counterclockwise is positive. Alright, so C is going to cause a moment about A, and we would say, and it's going to cause a positive moment. So we would say RCY times 16 plus 8 is 24 feet. Okay. Now the next moment is going to be due to one of these forces. You can choose either one you want. And we'll just start with this 10 kip force in the Y direction. Okay. It's going to cause a negative moment, so it's going to be minus 10 kips. Okay, and that Y direction force needs to be moved or translated 8 feet. Okay. Alright, the other one's also going to cause a negative moment. It's going to tend to cause a clockwise rotation, but its distance is going to be this 10 feet, so it would be minus, oops, sorry, put the minus in, 10 kip times 10 feet. Okay. So when I rearrange all that, I'm going to get RCY is going to be equal to, let's see, 10 times 8 is 80, 10 times 10 is 100, 180, so it'll be 180, that's divided by, and that'll be kip times feet, divided by 24 feet. Okay, and if I've done my math right, that should be, let's see, about 7.5, I think. 180 divided by 24, oops. Yep, 7.5 kips. Okay, so the only thing we need now is our AY, and so we'll do sum of the forces Y. Okay, and they're going to be equal to our AY plus 7.5 kips minus, okay, the only external Y force is a 10 kip force, minus 10 kips. Alright, and all that's equal to 0. Alright, so when I do that, I get our AY is going to be equal to 2.5 kips. Okay, let's go back in and label all our forces here. Oops. Alright, let me slide that up for you there. Okay. Alright, so now you can kind of see where that's going. We got to pick a joint to work at now. Alright, so how are we going to do that? Honestly, you could pick A or C. Both are solvable at this point. Just so let's just pick one. We'll pick C. Okay. Okay, so joint C. Excuse me. Alright. I'm also going to draw joint C for you, just in a simple way. Okay. And then take this. Alright, and let's also do, we've got to draw FBC and FAC. Okay, so the only thing that can give us a Y direction force to counterbalance this one, RCY, is from BC. So since this is going up, we know that this one has to go down, right? Okay, and since this, to get this y direction right, is going to the right, we've got to draw AC, which is all x direction, going to the left. Okay, so let's label those. Okay. Scoot all these over. Yay, there we go. Okay, so there we've got joint C. Okay, now that we have this, okay, remember we found that angle, right? And it was 32 degrees. Oops. One other thing I just want to go over quickly as a reminder, remember that when we draw this, okay, right, and then we also will have this configuration. Okay, these are forces at joints, okay, and remember that when we draw the one where the arrows are pointing towards the joint, okay, we say that member is in compression. And we say this one is in tension, right? So remember that when the arrow points away, the member's in tension. When it's towards, it's in compression. Alright, so now to do our calculations for this, what we need to do is, I know this one, okay, RCY, and FBC is the only other y component, so it does make it kind of easy for me. So I think I'm going to do sum of forces y. Those are going to be equal to 0, okay? And then when we look at this, we know that we have 7.5 going in a positive direction. And then we have minus FBC in the y direction. So that's going to be equal to 7.5 kips minus FBC times the y component would be the sine of 32. Oops. Wow, you gotta love it when you hit your keypad. Okay, 32 degrees. Alright? So, from that, I'm just going to make that a little longer. Okay. So when we solve that for FBC, we're going to get it's equal to 7.5 kip divided by sine of 32. So FBC is going to be equal to, let's see what I got here. I get 14.2 kips. Okay, and let's look how we drew that so we'll know whether that's tension or compression. Okay, it's going towards the joint. Okay, so we said that is compression. Alright, now let's do sum of forces X to get FAC. That's going to be equal to 0. Okay, so FAC is going in a negative direction, BC is a positive X direction, so it'll be FBC times the cosine of 32 degrees minus FAC. Okay, so that's going to be equal to 14.2 times cosine 32 minus FAC, and then from there we get FAC is equal to what did I get here? Let me double check my math here. You get 12, so 12.0 kips. Oh, that's right, okay. And the way we drew that is away from the joint, so that's, look right there, tension. We put a capital T. Okay? Alright, so now if we just do joint A, because we know AC, we know BC, all we need to know is AB. So let's just do joint A quickly. Okay. Okay, now I need to draw in FAB. Alright, this one's going up. Okay, this one's going that way, alright, to the left. Alright, so when we look at joint A, what is joint A going to look like? Alright, something seems, oh, I've left a force off, that's what's wrong. Hello. Okay, then I also have, let's do, alright, I got FAC was 12 kips in tension. Okay, so it needs to go away from the joint. Oops, sorry. Now I need to draw in FAB. Alright, it's got to be coming down. Okay, and so that's going to be FAB. And how did I know it had to be coming down? Well, it had to be coming down because it's the only y direction force that is going to be equal to this y direction force coming up from RAY. Okay, we also know that this angle was, what did we say, 51.3 degrees. Alright, so now let's go ahead and solve joint A, and we can do it simply with sum of forces y. So we have 2.5 kips minus FAB sine 51.3 degrees Okay, and that is going to be equal to FAB. Then when we solve for that, it's going to be 2.5 divided by sine of 51.3, so it'll be 3.2 kips. Okay, look at how we drew it. It's going towards the joint, so it's in compression. Right? And that does it. Hope this helps.